for section 11.2, we're going to go over arithmetic sequences and series. So this is a specific type of sequence, and last section we did do a couple that are actually arithmetic sequences. Now we're going to go over specifically how we can write the rules for those and how to identify them. So for your vocab, the first part is there is a consistent value added or subtracted to each term to get to the next one. So if we're adding 3 every single time, that's going to be an arithmetic sequence. If we're subtracting 10 every single time to get to the next term, that would be an arithmetic sequence. With those, we are going to be talking about that amount that it's changing by. That is called the common difference, and it's going to be represented by the variable d. So again, that's the value that is added or subtracted to get to the next term. And then for arithmetic series, that's the sum of the terms, so when we add them all together. So for example 1, they want you to decide whether the sequence -4, -1, 2, 5 is an arithmetic sequence, and then explain. So if we look at this one, to get from -4 to -1, we are adding 3, and -1 to 2, we're adding 3, and 2 to 5, we're adding 3. When you are checking these ones, you want to check all of the terms that are given to you in the sequence, because sometimes the first couple of differences would be the same, but then when you get to like the last one or the second to last one, it changes, where you might be adding 5 instead of 3. So make sure you check all of the ones in the list. So this one, it would be yes, and that is because it has a common difference. Okay. So then the next part, we do have a rule for our arithmetic sequence. This rule will be given to you on a formula sheet. You do need to memorize how to use it, and then also you'll have to do a matching before you get the formula sheet. With the arithmetic rule, the a sub n, that is the outcome or the result for our terms. The n value, remember that gives us our term number, and you treat that the same way we would an x. So if n equals 20, it's the 20th term. We already talked about how d is the common difference. And the variable c, that is just going to be our constant. Okay, so we're going to use this rule to practice writing rules for specific sequences. So for example 2, they want you to write the recursive and explicit rule for the nth term of 49, 38, 27, 16, 5. Then we're going to find a sub 20. So let's look. First, we need to identify, is it an arithmetic sequence? So to get from 49 to 38, we would need to subtract 11. Same thing here, minus 11 and minus 11. So this one is an arithmetic sequence. That means we can use the rule above to write our explicit rule. So it's going to start with a sub n equals. We know the common difference is -11, so we would have -11n, and then we just need to figure out, are we adding or subtracting anything to get the numbers 49, 38, 27, and so forth. So remember, the first term is when n equals 1, the second term is when n equals 2. So we're going to pick one of these terms, or the result, and we're going to plug in the n value in the term to figure out what c equals. So the result, or the term value, was 49, and that will be equal to our common difference times n plus c. So we'll have 49 equals -11 plus c. When you get to this spot, you are allowed a calculator, so make sure you're double checking that you are doing the correct inverse operations. This is where a lot of people make silly mistakes. So we would add 11 to both sides, and that would give us 60 equals c. So to finish our explicit equation, we would just put plus 60. Then we can write our recursive equation. So for recursive, remember there are two parts. You're going to put a sub 1 equals 49, and then you're going to write the rule. A sub n equals, and we'll do a sub n minus 1, and then we show what's happening to get to the next term, which in this case, we're subtracting 11. Now we have the two rules. They want us to find a sub 20. When you are finding a random term, it is going to be easier if you use the explicit rule. So we're finding a sub 20. So that tells us n equals 20. And we are going to simplify. So if you just type that into a calculator, you would get a sub 20 equals negative 160. All right, if you would like to pause it here and try example 3 on your own, I would recommend that. All right, so for example 3, they want, again, the recursive and explicit rule for the nth term. So I'm going to find if there's a common difference, and this one there is because we are consistently adding 7 to get to our next term. So that means I am able to use the arithmetic sequence rule when I write my explicit equation. So I'll have a sub n equals 7n, and then I need to figure out if I'm adding or subtracting anything. I'm going to again use my first term when n equals 1 to solve for my c value. So the result or the term was negative 4 equals, and I'll have 7 times my n value of 1 plus c. Then I'm just going to solve for my c variable. So negative 4 is going to equal 7 plus c. And again, careful with your inverse operations. This one should be negative 11 equals c. And that finishes our equation. Then for our recursive rule, we start with a sub 1 equals negative 4. And then we write our rule, a sub n equals a sub n minus 1, and we state what is happening to get to the next term, plus 7. There we go. Then we're going to figure out what a sub 24 is. Again, it's going to be easier and faster to use the explicit rule, because the recursive rule, we would need to know what a sub 23 is, which we do not know that, and it would take us a while to get there. So we're just going to do 7 times 24 minus 11, and that will give us our 24th term, which equals 157. There's our answer. All right. Example 4, this one says one arithmetic term of a sequence is a sub 7 equals 5. The common difference is d equals negative 7. They want you to write the explicit rule for the nth term. We've already kind of gone over this. It's how we write the explicit rule from the previous ones. So we have a sub n equals our common difference times n plus c. They told us the common difference was negative 7. They give us an n value, and they give us a term that we can plug in for a sub n. So if we plug all of that in, we can figure out what c is. So we'll have 5 equals negative 7 times 7 plus c. So 5 will equal negative 49 plus c. So I'll add 49 to both sides, and I get 54 equals c. With these ones, make sure you are reading the directions so you don't forget to answer the question. So then we need to write our explicit rule. So we would write a sub n equals negative 7n plus 54. And that is our explicit rule. Doesn't ask for the recursive, so we do not need to write that for this problem. All right. The next example, this time they give us two terms of an arithmetic sequence. A sub 7 equals 20 and a sub 23 equals 52. They want you to find the explicit rule for the nth term. When they give you two terms like this, you are going to write two equations. So I'm going to use the first term to write one equation. So I'll have 20 equals my common difference, which I don't know yet, times n. And in this one it's 7 plus c. Then I'm going to use my second term to write another equation. So the term was 52 equals my common difference times my n value of 23 plus c. So we have two equations and two variables that we are solving for. So we're going to solve using a system of equations. You can use whatever method you would like. I'm going to do elimination because that one's going to be the fastest. So we'll have 20 equals d times 7 plus c. And we are going to subtract each of these terms so that my c values disappear, because c minus c is going to be 0. So then if I do 52 minus 20, that gives me 32. And I have 23d minus 7d. And that would equal 16d. And then I divide by 16 and I get my d value of 2. Once I know what d is, I plug it into either of my equations. I'm just going to plug it into the one I have written over here. So this equation, we have 20 equals, now my d value of 2, times 7 plus c. So 20 is going to equal 14 plus c, subtract the 14, and I get my c value of 6. Now remember, on your formula sheet, you are going to get the setup of a sub n equals dn plus c. Just make sure you are double checking that you put d in the correct spot in your equation. Same thing for your c value. So for this one, you should have a sub n equals 2 times n, and then plus your 6. And that would be your explicit formula. All right, now that we have that, we can go ahead and answer part B. For that one, they want you to find the value of n for which a sub n equals 44. So for this one, they told us what the outcome equals. So I'm going to set that equal to the rule that we just wrote for part A. And then I'm going to solve for n. So I'm going to subtract 6. That'll give me 38 equals 2n. And then divide by 2, and that would equal 19. So this would be the 19th term of our sequence.